In software engineering, we are taking chapter number 30, product metrics. So it's all about the software, and we would like to discuss certain metrics. But software involves various processes in software development life cycle. So the metrics related to process are process metrics. Finally, software as a product with all the deliverables. Then we have the matrix, and software is made in a project. So that project, all the estimations, all the values, empirical discussions, that will come under the project metrics. So what we are going to discuss is the metrics can be project based metrics, and it can be design based metrics. The project based metrics, as I just showed you, process, product and resources. In the design based, the traditional or the conventional softwares we were using. And then the second type is the object oriented, where the object is the key. So the design based metrics on traditional can be the cyclomatic complexity, it can be the line of codes, the CP, etc. All these we are going to discuss. Along with this, the object oriented like the CK and mood, this also we are going to discuss. In software world, we know that we have number like 5 volt or 3 kilogram or say 21 degree centigrade. These are specific value, and you can directly measure these values using various devices, instruments. But the problem in the software world is because it is still evolving, and previously we were making conventional software, then object oriented, now web apps, and now mobile apps. So things are changing so fast. Direct measures are quite uncommon in software world, but still we need to measure. So we will discuss the measure that can be employed or used to assess the quality of the product, or you can say the software or the application or any app as it is being engineered. That is, we are talking about quality here. So we would like to measure. Until we measure, we will not be able to understand the attribute or what is the qualities. So these measures of internal product attribute provide us with certain things. As I said, the product when it is being delivered or about to be delivered, before that we need to measure certain things. First is, in the software life process, we have requirement engineering, requirement modeling, then we have design and architecture, then the code modeling. So this requirement, design and the coding, these measures will give you a real-time indication of the efficacy of all this. When we will write the test cases can be employed to any work product generated during the life cycle of a software. So what is the effectiveness of these test cases? We need to measure it, whether it is good, whether it is bad, whether we can employ it, are these test cases going to work, and the overall quality also. Measures, metrics and indicators. These are the 3 things we will be talking, and they are quite close to each other. Measure, the measure is map. Measurement is map now. Okay, let me tell you. The measure, it provides a quantitative indication. That is, we are talking about a number. So measure will give you a number, a value. So this will give you a quantitative indication of what is the extent, what is the amount, what is the dimension, what is the capacity or the size of certain attribute or a property of a product or a process. I hope you got the idea. This measure will give us a number of various aspects of certain attribute of a product or a process. So these attributes can be multiple, like the completeness, like the efficiency, like the reliability, like the availability. So these are what I have spoken are also the quality attribute. Now the measurement is the act, is the work of determining a measure. What is matrix? Now IEEE gave a very good definition for metric. This metric is a quantitative measure of the degree. So here degree has come. A quantitative measure of the degree to which the system or a component or a process possesses a certain attribute. For example, take the example of reliability. Now this is an attribute of any product or a software. So the quantitative measure of the degree to which the system, so just understand we are talking about a system or a component or a process. Now, it can be anything. So this reliability in that system or a component, what is quantity measure of the degree to which this attribute is present in that component. So this matrix relates the individual measure in some way. Okay. When we are attending or we are collecting a single data point, let me take an example of a software component. Now we need to test it. There are certain errors will be uncovered. So when we take a number in a single software component, these numbers of error has come. We have established a measure. What is a measurement? This is the one data point we have just collected. But now let us move to more data points or more collection points, more way of collecting. So same component, when we are able to do it in multiple ways, for example, we have same component, we are doing the reviews, say the technical review. And then this can be done multiple times, or say unit test we are doing. So the number of component reviews and the number of unit tests, now we are having multiple data points, and this is also we are using to collect the measures of the number of errors for each. So here we have two data points. Previously it was one data point. Okay. So when we establish the measure, then we go to multiple data points in order to collect more data, and this becomes a measurement. When we have multiple data points, it becomes measurement. So a software metric relates the individual measures in some way. How do we relate? For example, we found some certain errors. So the errors found per review, and what is the average of these errors? That is the number of error per review. What is the average value of these errors per review is a metric, or the number of errors per unit test. What is the average rate? This is a metric. Okay. Now indicator. Indicator is when we take a matrix or you can say combination of these metrics that provides us with the insight into a software processes or a software project. So indicator will indicate through certain combination of values, and this indicator is why we are calling it as an indicator, because it is going to indicate the software team, for example the project manager or a software engineer, that this is the indication, this is what you are getting, this is the number. And on the basis of this, for example 4 is there, you need 2, 5 is there, you need 3. So now the project manager can adjust the process and project on the basis of these indicators. Measurement principles. Now Roche, he suggested a measurement process is characterized by certain activities, namely 5 activities. So in order to do a proper measurement process, first formulation has to be done, collection, then the analysis, then the interpretation, and finally the feedback. So these are the steps you can say, or these are the activities involved for a proper measurement process. That is what we want to do. Then we will collect the information or the data. Then we will try to analyze what we can do with this, in which way we can use it. Then we interpret, that is quantitative way, and then we'll give the feedback to the person or the people which are concerned. So the metrics, there are certain principles also, how to characterize the metric and also how to validate these metrics. Because metric cannot be just thought in a dream. You have to have certain properties for a metric. For example, a metric should have a desirable mathematical properties. It cannot be subjective, it cannot be objective. Metric value should have a meaningful range. Okay, that is, for example, you say 0 to 1, what does it mean? 0 may mean absence of certain attribute or degree of content, or you can say 1 is the presence. If minimum maximum we are saying 0 is minimum, 1 is maximum. So 0.5 will be what? It will be halfway point. So mathematically it can be defined. And the increasing and decreasing nature, when a metric represents a software characteristic. For example, we are taking example of usability. Now when it is increasing, the positive traits are occurring, it is increasing. When undesirable traits are occurring, it is decreasing. So in the same way, corresponding way, the matrix should also increase and decrease in the same manner. That is, it should show the correspondence. Then each metric should be validated empirically in a wide variety of context before being even given or published. For example, we can do empirical validation through experiments, case studies, surveys. We can use proper mathematical modeling, mathematical concepts to formally validate these metrics. But before being published or making decision, we need to do it. In the measurement principle, it is very important to understand that the formulation, characterization and validation, these are critical. But a measurement process always is driven by collection and analysis. If we can collect the data properly and we can analyze the data properly, the numbers properly, the scene properly, scenario properly. So Roche suggests, whenever it is possible, the data collection and analysis should be automated, because nowadays we have huge data. Okay, the data is going exponentially, the content volume wise. So we have to be very sure about the automation. The next thing is, we need to use, or some valid statistical techniques should be applied, because a product can have an internal attributes, it can have some external attributes, quality attribute. So in order to establish a relationship between the internal and an external quality attributes, we have to use some valid statistical techniques. For example, see, if we have a software, the architecture is overall structure of the software, the architecture complexity. Now, does this architectural complexity relates with the number of defects reported in production use? When the complexity is higher, defects are higher, complexity is lower, defect is lower. So we need to apply and validate using this statistical technique in order to say that we are doing proper measurement. Along with this, with each metrics, we need to have certain interpretation guideline, certain recommendation that this metric will do this thing, this metric will give you this indication. Goal-oriented software measurement. The name is suggesting there need to be a goal. We are calling it as GQM. G is for goal. On the basis of goal, there will be certain questions. And on the basis of these questions, the answer will tell you the metric. So this GQM paradigm was developed by Vasily and others for identifying the meaningful metrics for software processes. For software processes, what will be a proper way for this software measurement? Now, this GQM is emphasizing on what is your goal, what is your explicit measurement goal that is specific to a process activity or a product characteristic. Then we will try to define certain question, and that question need to be answered because these are to be answered in order to achieve the goal, measurement goal. And then we will identify well formulated metrics that will answer this question being formulated with respect to the measurement goal. And then we'll make a goal definition template, and that will be used to define each measurement goal. So I'll show you that this goal definition template just now. But before that, let us understand what this means, goal oriented software. For example, the goal is effectiveness of a new programming tool. We would like to evaluate it. What is the effectiveness? Okay. So it can be we were using some C and C++, now Python has come. Now we would like to understand how this Python is going to work in this scenario. Now the first question can come is, who is using this tool X? It can be Python. Now the question can be, say 100 coders are there, 100 people are there. 20 of them are coders, 100 of them, 20 are coders. Now experience of the coders, some of them may have 5 years of experience, some of them may have say 3 years of experience. And you can say that the people who are not coding also, they can also have experience, right? So this is the metric. Metric is coming from proportion of coders, the experience of coders. Let me take one more question. What is coder productivity? If you want to use this tool, what will be the code size? How many line of codes a coder can write? 100 or 1000 or say 10 only? What are the function points? We'll discuss about that. Just understand it is functions, procedures or methods. The next question can be, what is code quality? If someone is writing in Python, how many defects will be produced? What effort has to be put in? This is how the metrics will come from the question being answered with respect to the goal which has been decided. See here, this is the goal. So at the conceptual level, measurement goals involve product, processes or resources. These are the goal. Then coming to the question, at the operational levels, question try to characterize the object of measurement in the context of a qualified issue from a particular viewpoint. These all questions are going to fulfill the goal. And what is the answer? These are metrics. So these are at quantitative level. These are associated with every question. This is a set of data, either subjective or objective, that help us to give a number, a quantitative number. Okay, so this is GQM or goal question metric, GQM. I told you that we'll make a template, and that template will give you the actual scenario. If you remember, this is a safe home product which is employing a software. Now the GQM, when we apply here, the template will answer like this. Let me tell you the template first. Analyze, inside which we are going to give the name of the activity or the attribute to be measured. For the purpose of, inside this what we will give? The overall objective of the analysis. Then we have with respect to, what we are going to write here? The aspect of the activity or attribute that is being considered. Analyze for the purpose of, with respect to, and then we'll write from the viewpoint of. What we are going to write here? the people, the stakeholder who have interest in this kind of measurement. Then in the context of, that is the environment in which the measurement has to be done or measurement takes place. So this is the template, and for every question we are going to fill it. So let us fill it and see what we can do, because we have to start with the question. The template will be fulfilled. For example, the template for safe home will be like this. We need to analyze what? The safe home software architecture. For that we need certain metrics. So the software architecture is the overall structure of the software. Like how are the components, how they are interfaced. What will be the second one? For the purpose of what? We need to evaluate the architectural components, because we have to answer the overall objective of the analysis. Because the name of the activity or attribute to be measured is software architecture, and purpose is evaluation of architectural components. And what is with respect to? We need to write the aspect of the activity that is to be considered. So with respect to, here we will write the ability to make safe home software or the product more extensible. From the viewpoint of who is having interest? The software engineers who are performing this work, who are going to do this extension. In the context of the environment in which measurement has to be taken, so product enhancement over the say next 3 years or 5 years. So this is how we make a template and fill it. With a measurement goal, when we are explicitly or specifically define the goal, as we shown you certain questions in the example also, and this helps the software team to determine certain fact whether the measurement goal has been achieved. Because the goal is defining the question, the question is defining the metrics, and vice versa. For example, the question is, are architectural components characterized in a manner that compartmentalizes function and related data? That is, if you have a component, say you have a class or simple module, do we have the function and data which are related so that we can compartmentalize, we can modularize it? Okay, these architectural components, are they like that? So they are modular so that we can be extending it. The second question can be, is the complexity of each of these component or the module within bounds that will facilitate modification and extension? Is there any problem in modification? Can it be modified or extended? Or do we have some, say, roadblocks in doing that? So these are the questions which are being asked. And depending upon this question, because the goal is very much defined, the answer should be quantitative. It needs to give a number. That is why we are calling about metrics. So metrics that provide an indication of cohesion of an architectural component might be a very good answer for your Q1. That is what is the cohesion? Cohesion is if a module or a component does the like-minded activity or just work what it is being designed for. This is the answer we can give. So I already explained you the example which is above. Function-based metrics. This we are going to see in the next discussion. And then thank you so much. Take care of yourself.